Alright, so guys, we don't have a lot of time today. We only have like 40 minutes. We usually have like 80 minutes, so we have like half the class today. But what we have to get through is not a lot. If you look at the notes, there's not that many examples. And a lot of this stuff doesn't even really deal with having to like do any type of like arithmetic. So we should be able to get through it. And then we'll talk a little bit at the end of the lesson in terms of us having, we may have another delay tomorrow because they're talking it being like 22 below zero tomorrow morning with the wind chill. So there might be a delay. All right.
What about no school?
I think we'll have school. All right. So guys, we're gonna take a look at. We're going to take a look at today, guys. You probably obviously don't know what these words mean yet, but interpolation, extrapolation, causation, and correlation. We're going to look at those three things today, okay? We're still, you're out of here. Your lunch today, I no mistake, I got the schedule up when I came up here. Your lunchtime and stuff is still going to be at the exact same time. 10:39 to like 11:06 or something like that. Period 5 and period 6 are the same time. There's no change with that. That's what happens after that. When we're done with the lesson, guys, we have time. We'll put that schedule back up there for you so you know exactly what's happening. All right? So, guys, on your notes, you get a couple blanks to fill in. Using a graph or its equation to approximate a value between two known values is called interpolation. All right, we're gonna look at that in a second. Basically, what you're gonna do is what we're gonna do is we're gonna take a number and plug it in for an x or y value. That's what we're gonna do for that. Using a graph or its equation to predict a value outside the range of known values is called an extrapolation. Right? So here it's gonna be approximate. It's gonna be exact. Here you're gonna predict. So interpolation, it's exact. Extrapolation, you're predicting, you're making a guess based on the equation on the line. So in general, you have this written on your notes, in general, the farther removed the value is from the known values, the less confidence you can have in the accuracy of the prediction. So if the number you guess is like way outside the known values, then it's not going to be a real good fit. All right? Let's look at an example. All right? So in like Yellowstone National Park, you may have heard of like Old Faithful. It's a geyser. It's like water in the ground, and every so often, like the water sprays out of the ground. All right. You can use this equation to predict. So this is like your line of if we had like a scatter plot with all different like when the time of day the geyser erupted based on how often the geyser erupted and how long the eruption took. That's something that we could look at. All right. This would be what giving you the line of fit. This is it right here. So that would be the line that would if we had to graph all the different data, that would be our line of fit. The y equals 12.0x plus 35. All right? But each of these values, the y and the x, they represent certain things. All right? So the y is going to represent the time until the next eruption. How much time is going to go by before the next eruption happens. All right? And then your x is going to stand for eruption duration, which means how long the eruption lasts. All right? So this is going to be how long it takes for the next eruption. That's going to be how long the eruption takes. So that would be our graph, right? On the bottom would be numbers. That would be it would be labeled time until next eruption. And then on my x on the bottom, that would be my eruption duration. My y on the side, going up and down, going vertical, that would be my time until the next eruption. All right? But again, we don't have to graph it now. We're just saying if we did graph it, this would be our line of fit based on that information. All right? So now, if we go, now, let's go back real quick. Now, we're approximating now. So is that interpolation or extrapolation? We're approximating. We want it to be approximate. We just wrote them down. Is that going to be interpolation or extrapolation? Okay. Yeah, right? If we go back, it's going to be an interpolation, right? Because we're using the equation to approximate. We're trying to get it pretty exact. All right? So give me the information. Let's see what we're asked to do. So approximate the eruption duration if the time to the previous eruption is 77 minutes. All right? Approximate the eruption duration if the time to the previous eruption is 77 minutes. So we have two variables, right? We have the y, we have the x. Based on what this tells me, which variable do I know, the y or the x? It says approximate the eruption duration if the time to the previous eruption is 77 minutes. Do we know the y or do we know the x? Did it tell us how long in between eruptions or how long the eruption took? That's 77 minutes, right? What does that represent? How long the eruption took or how long in between? Gigi? No, it's asking me to approximate the eruption. It says right here, we want to approximate the eruption duration if the time to the previous eruption is 77 minutes. So basically what this means is the last eruption was 77 minutes ago. So is that going to be my y or is that going to be my x? Someone tell me by raising their hand. Nicole? That's going to be my y, right? Time until next eruption, or it gives me the time from the previous eruption. So instead of, when I set up my equation based on this data, right, instead of y, what am I going to write? Garrett, instead of writing y, what am I going to write? 77, right? Because I know that now. 77 equals, what am I going to write next? 12. Do I know my x? No, because that's what I'm trying to find, right? I'm trying to approximate how long the duration of the eruption was, because I know it was 77 minutes ago. So I'm going to leave it as x. What's the last thing? Plus 35. Now I'm just going to solve this just like solving a regular equation. All right? So first thing I'm going to do is what? What do you think, Brady? What's the first thing I'm going to do? What do I want to get by itself? I only have one variable in the question now, right? I want to get x by itself, so what do I do? Thank you, Yusuf. We just want to... Right, so like Brady just told me from Yusuf, right, I'm going to minus 35 on both sides. All right, so now I'm going to do, this is going to cancel out. 7 minus 5 is what? 2. And then 7 minus 3?
3. 4. 4.
All right, so guys, all I did was I ran out of space, so I took it and wrote it over here. Equals
12.08.
And again, if you just wrote 12, if you wrote it without the decimal of 0.0, that's okay too, doesn't matter. You don't have to put it, it's still 12. One more step here. I've figured out the duration of the eruption. Donovan? Divide by what? 12. X equals. Does this come out evenly?
No.
We'll do 42. 3.5. Alright, so X is 3.5 what?
Minutes.
We're dealing with time, right? So it's going to be minutes.
Yes.
Alright? 3.5 minutes. Now, how long until the next eruption if the previous eruption was 5 minutes? So now it's just the opposite.
It's add.
So in this one, I was able to plug in for Y. Mary?
You're going to put that in for F.
I'm going to plug in for X now, right? Same exact equation, But I'm just gonna plug, because now this time it gives me the eruption duration. It was 5 minutes. So it's gonna be y equals 12, let's gonna put 12. And then parentheses, what number am I gonna plug in for x again? 5, good. Plus 35.
So 12 times 5 is 100.
Nope. Y equals 12 times 5 is 60.
Whoops. I was saying 100. And that's going to equal 95?
Yep. 95 what?
Minutes?
Yep. So again, all that's happening with this, guys, is we're gonna give you the equation. You just have to make sure you plug in for the correct equation, or the correct variable, I should say. All right. Good with this? All right. Now, again, we're gonna use that line of best fit again. All right, someone tell me what it was. Y equals what? Plus what? So we're going to use that exact same line of best fit just for some other data. All right, so approximately how many students would be at a school that has 20 teachers? So same deal. What do we plug in for first last time? Y or X? Mary?
We put in for Y was for this one. When you plug it in for X.
So we're going to plug in for X or Y here.
It would make. Can I show you what I did? Because I solved it.
Sorry.
Mr. Ross.
Yeah.
Can I show you what I did? Because it would make more sense that you would need.
So we need to know what that equation represents. To know what X and Y.
Okay, so we want to say X is teachers.
Where is that formula from?
Well, it says use example 1, that line of fit.
Okay. Do we have example? Can we go back to example 1?
Okay.
So that has to do with number of teachers, or is that for the Old Faithful?
This is for Old Faithful, but it says we're using that same line of fit.
Wouldn't that be a logic question? Because wouldn't you have more students than teachers?
Want to skip it?
I think we should, but that's a big decision.
All right, so guys, we'll come back to that example. All right.
I like that one.
Steve, you want to get that? You want to start the thing for me? Good. Okay. All right. So guys, like I said, we'll come back to that one. All right, Yusuf, you okay today?
I'm fine.
Just making sure, man. Very talkative today. All right. So now, so we talked about interpolation. We talked about extrapolation. We're also going to talk about causation today. So that means that causation produces a strong correlation between two variables. Like when we talked about like Old Faithful. The time, the X and the Y, right? The time between eruptions and then how long the eruption lasts. That's going to be a strong. That's causation. It makes sense. Each thing will affect the other. One thing will affect the other, right? The longer in between eruptions, the longer the eruption's going to be, because that water and stuff underground has more time to build up. All right? Or the more, for school, the more demerits you have, chances are it's going to increase the likelihood of you having in-house or getting suspended. Right? The two things work together. Right? They're connected. All right? But the kind of food you eat is not going to affect at all what your grades are going to be on a test. Those two things don't really affect each other. All right? They might, but it's not really strong. So do you want to say something?
Yeah.
Okay.
All right, so I think the easiest way to go through is just to kind of look at some examples and you guys can see the difference between causation and correlation. It's kind of weird.
You may now proceed to period 2.
Congratulations, you're already here.
I'm sorry.
All right, so let's look at 3A. Okay, this is saying that the time spent exercising and the number of calories burned. That's the situation. So we want to determine two things about it. One, is there a correlation? Two, is it a causal relationship between them? All right. So let's figure out first if there's a correlation. All right. Let's do that first. Because if there's no correlation, then you don't even go to the next step and look for a causal relationship. So you check if there's a correlation first, and if there is, then you check if it's what we call causal, right? So let's take a look. So correlation, right? So we looked at that yesterday. If you were to make a scatter plot of how many minutes people exercise and how many calories they burn, do you think when you look at the dots they would be random?
No.
Or do you think they would be kind of a pattern to them?
Yes.
Yeah, I think there would be a positive correlation. I would say the more minutes that you exercise, the more calories you're going to burn. Okay, assuming you're comparing the same exercise to the same exercise, not like comparing somebody running to somebody biking, because then that's different. One exercise might burn more calories than another.
The same exercise.
So for the same exercise, going at the same speed, if two people do that exercise and one person does it for 20 minutes and another person does the exact same exercise for 40 minutes, I would say that they're probably going to burn more calories, assuming the person's the same weight, things like that. So we agree that there's a correlation.
Yes.
And we agree that more minutes exercising equals more calories burned.
Yeah.
That's positive then. So tell whether there is a correlation likely. Yes. There is a positive correlation.
Yes, like you can see on the next, like example 4, for the 3 we're going to do under example 4, there's actually space where it says, is there a relationship, then you have to explain. Just for these, this doesn't have that.
Now, if there's a correlation, we're going to take it one step further and figure out, is there a causal relationship? That means if you change one of the things, it would automatically change the other one. So if you change the number of minutes you spend exercising, will it automatically change the number of calories you burn?
Yeah.
Pretty much, yeah. If you're doing the same exercise and you're working just as hard the whole time, you don't change how hard you're working, and you do that level of effort for 20 minutes, and then you say, you know what, I'm going to do the exact same level of effort for 15 minutes, you're going to burn less calories, right, if you're putting in the same amount of effort. So here we would say there is a causal relationship. So yes, there is a causal relationship. And if you're not sure, you'll see when we do the next one where there isn't a causal relationship, and then I think it'll make more sense. So yes, there is a causal relationship. Okay, let's look at another situation. The number of banks and the population of a city. So, do you think we're going to figure out if there's a correlation. So I'm kind of picturing a scatter plot in my head. If I were to make a scatter plot with how many people are in a city and how many banks there are in the city, do you think I would notice a pattern?
Yeah.
On average? You think like a city like Boston, bigger population, would probably have more banks in it than like a small little town like Templeton.
Yeah.
Smaller population. Yeah, I would say there's probably a positive correlation. If you've got a bigger city, you probably have more banks in the city, right? So and it's positive. More people, more banks. Right? If it was like less banks, well, then that would be like negative. Okay? More people, more banks, I would say yes. There is a positive correlation. That means there's some kind of connection, most likely, if you were to look at the data for cities in the United States, that you'd see a pattern, maybe like this if you graph the dots. Now, the next thing is it causal? If you change the number of banks in a city, if you build a new bank, will the population automatically go up?
No.
No. Changing one doesn't automatically change the other. All right? If Fitchburg goes and builds 3 new banks today, it doesn't mean that all of a sudden we're going to have 100,000 new people. It doesn't. Changing one doesn't automatically change the other. So no, I would say there is not a causal relationship. And you could also look at it the other way.
It's not an A or an O.
What?
Because causal is in an A or an L.
CAUSAL. So if, let's say tomorrow, 200 new people move into Fitchburg. Well, it doesn't automatically mean that there's a new bank. It doesn't work that way. If 200 people just show up tomorrow, it's not automatically a new bank. Versus the exercise where if you automatically work 10 more minutes, you automatically are going to burn more calories. That's a causal relationship. Okay? We have another one of those, right? Okay. Let's look at this one. Okay, and then we'll go back to the teacher problem. All right. So tell whether a correlation is likely. So that's what you have to determine first. If there's no correlation, you're done. You're done. Can't do anything else. Tell whether a correlation is likely. And if it is, take the next step and say, is it causal? Does changing one automatically change the other? Okay. So the amount of time spent talking on a cell phone and the remaining battery life. Do you think that if you made a chart with how many minutes, just take your phone, don't compare your phone to someone else's phone, that's different. Take your phone, you talk on it for 20 minutes, and then you talk on your phone for 40 minutes. Do you think there's going to be a connection with how much battery life you have left?
Yes.
Yes. Is it going to be positive or negative?
Negative.
It's going to be negative. The more you talk, it's not going to be the more you talk, the more battery you have. That'd be positive. That doesn't make sense.
Yeah, if you're on a charger the whole time.
Well, yeah, pretend it's not charging, because if you're charging, then the battery wouldn't change at all. If it was like 100%, it would just stay at 100. But if the more you talk, the less battery you have, what kind of correlation is that? Negative. It's going down. So if you graphed your chart, it might look something like that. The more you talk, the less minutes you have. So is a correlation likely? Yes. Specifically, it's negative.
So guys, when you ask me for the correlation with these, you gotta tell them, you say yes, you gotta say whether it's positive or negative.
Now, because there's a correlation, we can figure out if it's causal. If you change the amount of time that you talk, does it automatically affect your battery life?
Yes.
Yeah.
Yeah, there's no way around it. If you
Yeah.
talk for 20 minutes and then you decide to talk for an hour, the battery life is automatically going to change. There's no question. It's got to change.
So when it says causal, guys, all I have to say is yes, all you gotta say is yes or no.
So this one is kind of like the exercise. If you exercise more, you automatically burn more calories. There's no way around it. Okay? But it's not like the bank one, because if you build a new bank, it doesn't automatically mean you get more people. That doesn't really make sense. All right, let's look at this one. The height of a toddler and the size of their vocabulary. Do you think if you looked at the heights of toddlers and how many words they know, do you think you would see a pattern? That if a toddler is taller?
No.
No.
Yeah, I mean, that one, I don't know. Just because a toddler is taller, it doesn't necessarily mean, you might think it means they're older. So I would say there might be more of a correlation if you look at the age. And I would say, yeah, that would be a correlation in the entire United States. If you look at the age of a toddler and how many words they know, there's probably a pattern. I'd say in general, as they get older, they probably start to know more words. If you look at like millions and millions of toddlers. Maybe there's some that don't, But I would say on average, they probably do. Now the height, I don't really think there's a connection with that. Because some people might grow slower, you know. So I don't really think there's a correlation there. And if there's no correlation, then
We're done.
yeah, there's automatically not a causal relationship. All right, the weight of a dog and the length of its tail. So well, think of it this way. Do small dogs ever have like huge tails usually, on average? A small dog usually has a smaller tail. It's kind of like the tail is usually kind of in proportion to how big the dog is, right? I don't think you'd see a huge dog with a tail that's like a ½ inch long.
In Puerto Rico, they cut the tail.
Unless they cut it, yeah. But if you keep it, keep it, normal, like don't cut it off. I would say there's probably a positive correlation between the size or the weight of a dog and the length of its tail. I would say if you look at all the different breeds of dogs, I bet on average bigger dogs have a longer tail than like a really small dog.
Like a chihuahua.
Yeah, like a chihuahua is not going to have a foot-long tail.
Or like a rat terrier. Rat terrier's got those.
But if you look at think of like a golden retriever.
Yeah.
They're like a medium-sized dog, and they've got a tail, and it's a
And then there's like a Great Dane.
much bigger tail.
Yeah.
All right. So I would say yes. What kind of correlation? Positive or negative?
Positive.
Positive. Bigger dog in general, bigger tail. Bigger dog, bigger tail. So yeah, I would say positive. Now, is that relationship causal? If a dog gains 10 pounds, is its tail automatically going to grow?
No.
It's not causal. Okay, if a dog loses 5 pounds, its tail doesn't shrink 3 inches. That doesn't make sense, right? So there's probably a connection, but it's not, or a correlation, but it's not causal. Okay? Any questions on the causal and correlation? We gave you guys 4 examples.
Do you want to go back to that other one or no?
Yeah. So we still have 20 minutes.
We have fit 19 minutes.
19 minutes. All right. So on your notes, flip back to example 2. All right. So there's a formula here that shows us teachers and students. It's a connection between like how many teachers in a school and how many students. Let's think if that's causal or if there's a correlation. Do you think you would find a connection if you graphed how many students in a school and how many teachers in the school?
Yes.
Yeah, I would say that if you look at like a school that has 3,000 students versus a school that has 100 students, there's probably more teachers in the school with 3,000. So on average, there's probably a correlation. Positive. More students, more teachers. Now, if Monty Tech gets 5 new students today, they transfer in, 5 new students. Are we automatically going to have a new teacher? Like, is that automatically, like, all of a sudden this teacher just appears out of nowhere? No.
If like 20 kids came in, then yeah, maybe.
No. Or if a teacher leaves Monty Tech today, do 30 students automatically just disappear?
No.
No. So,
Mr. Hager, if you left out of you.
okay. So there's not a causal relationship between students and teachers. If you change one, it doesn't automatically change the other, like exercise. You change how many minutes, you automatically burn more calories. There's no question. You can't. One changes the other. Right? It doesn't work like that with teachers and students. Right? So X.
I agree.
X is the number of teachers. So if we label this, then it'll make more sense.
Oh, that's low.
Y is the number of students. Now what we can do is we can use this formula to predict how many teachers and students there are going to be in a school. It's not necessarily going to be perfect, but it's It's a formula. Maybe they figured it out using the graphing calculator like we did. They looked at a bunch of data and found a line of best fit. So, approximately how many students would be in the school if there were 20 teachers? All you have to figure out is where the 20 goes. Does it go in for X or for Y? Yep.
It goes in for X.
Yeah, it goes in for X. So we're going to put Y equals, and now we're going to solve using our formula. 12 times 20 plus 35. Now again, this might not be perfect because like Mr. Roy said, it's a prediction. It's not a guarantee. It's just using the formula, it's the best guess we can make. All right. So 12 times 20,
24.
how much? 24 and then put a 0, yeah. 240. 240 plus 35 gives me,
275.
yeah, 275.
275?
So based on whatever data they used to get this formula, the prediction would be about 275 students in a school with 20 teachers. That's the prediction. Now we're going to make a prediction the other way. How many teachers would be at a school with 335 students? Now, before I do it, what kind of answer should you get?
An even.
What do you mean even? Whole number, right? You can't, in this kind of situation, it doesn't make sense to have like 22.6 teachers, right? So you really need to round it. If you need 22.6 teachers at the school, then you need to hire a 23rd teacher. You can't. You gotta round it, right? So approximate how many teachers you would need with 335 students. Where do I plug in the 335?
For Y.
Yeah, plug it in for Y. So 335 equals 12x. What's that, Joe?
Point zero.
No, usually if it's a point something, Joe, it means the teacher works part-time. Like if you're a teacher that works at like a 0.5 schedule, that means you only work half-time. That you're missing a leg.
Why is it missing?
Yeah. So, all right, we got that. Somebody tell me, how do I solve it? 2 steps. Yusef?
Minus 35.
-35. I like it.
Then it's going to be 300.
And my last step,
Divided by 12.
divided by 12.
That gets you 25.
So, based on whatever data they used to get this formula, the prediction for how many teachers you would need, well, let's do it out. 300 divided by 12, Donovan, you already did it. You got 25. Yep, comes out exactly to 25. And what is that? 25
Teachers.
teachers. So 335 students would be about 25 teachers.
That was pretty stressful.
Okay, so I'm sorry, we didn't have that labeled. I forgot or something. I don't know what I did. But the reason I was not looking is because
Guys, like 11 minutes. No need to pack up.
I was gonna try to find for you guys there's a phone number you can call, and it actually tells you like the next eruption of Old Faithful will be in 47 minutes. So you call it and it tells you. That's what I was trying to find. I thought you would have liked it. But I couldn't find it. I found it on the website. It actually told me like there's like a list.
You call.
I was in the middle. That's why I wasn't paying attention.
Guys, just for there is homework, and I think it's only like 7 questions. But stuff at the beginning talks about like the causal relationship, correlation, and the rest is kind of a review of all the stuff we've done this week. Tomorrow, we'll do the MCAS question. First half of class. Second half, we'll do the online test review. Now, make sure you bring your Chromebook to class tomorrow. Make sure it's charged. Alright, you're going to need it tomorrow, what we do. Alright, like I told you guys yesterday at the end of class, if you haven't already, go on to Google Classroom. Yusuf, go on to Google Classroom. It'll give you a link for Big Ideas Math. You click on that, all right? It'll send you to the website. You have to sign up and create an account for yourself. That way you can do the in-class review tomorrow. So try to, before you come to class tomorrow, sign up for Big Ideas Math. All right? Sign up for it. Use your Monitech username and password to get onto it. All right? And it'll give you a class code. The class code's on Google Classroom. So before class tomorrow, go on to Google Classroom, follow the information, and it'll sign you up for Big Ideas Math. Now tomorrow, if we do have a 2-hour delay, we're only going to have really like half the class. I know we still have period 1 and 2, but it's going to be half the time. We're only going to do the online stuff tomorrow, the review for the test. All right, if we have a delay tomorrow. Let's get you guys ready for that. Like I just said, go on to Google Classroom so you can sign up for the website. And then our first test of the third quarter will be on Friday. So guys, even if for some reason, someone mentioned at the beginning of class, if we have no school tomorrow, we will still have the test on Friday. All right? We've covered everything we need to cover for the end of this week. So understand, if there is no school for some reason tomorrow, we will still have the test on Friday. So don't come in here Friday morning and say, oh, I didn't know we had the test. I'm telling you right now. So those people that aren't paying attention right now, when you come in Friday morning and say, I didn't know we had a test, we didn't have school yesterday. We have a test Friday if there is no school tomorrow. We're having a test Friday regardless. 2-hour delay, no school, full day of school, we still have our test on Friday. You sir. Huh? Yeah, I'm gonna put that up. It'll be up by the end of the school day today. I'm gonna go do it after class. Alright? So, regardless of what happens tomorrow, we still have test on Friday. And like Yusuf just said, after this class, Mr. Hager and I will put together the reference sheet. It'll be up by this afternoon. It'll be up before you leave school today, so you want to print it up before you leave school today, you can.
Okay, and guys, what I'm going to give you right now then, just in case, I'm going to give you the MCAS question. You have 10 minutes. It's going to be due on Friday. All right? It's a scatter plot problem. All right? So it's just like what we did in class. So I'm gonna give it to you right now.
We're gonna do that for homework instead.
Want to do that?
Yeah.
Okay.
We'll do that for homework instead. The other thing I have will be homework on Thursday.
Okay.
Simple.
Then we can go over that. Then we can go over that. Then we can go on time.